In the today's class, we'll take up the next section of the syllabus, that is crystallography. Okay. So it is a study of crystals. So crystals are basically a form of solid. Okay. You know that there are three different phases of matter: solid, liquid, and gases. So in solids, you can find the nature of system called crystals. Okay. So crystallography is basically the study of crystals. Okay, study of properties and structure of the crystals is called as crystallography. Okay. So let us take the basics of the crystals today. So in nature, you can find three phases of matter. Okay, so they are solid, liquid, and gases. You can find the three phases of matter as solid, liquid, and gases. In solids, you can find two types: crystalline solids and amorphous solid. Okay, so two types of solids are observed in nature. One is called as crystalline solids, and another type of group of solids called amorphous solids. Okay, we will not bother about this liquid and gases here, because we will concentrate on these crystalline solids in this particular topic. So in solids, we'll concentrate on crystalline solids, or they are called as crystals. Okay. So how these crystals are defined? So what are the important properties of the crystals? They are found in nature. Let us take that. So basically, the solids are classified into two types based on the structural type. So the two types of solids are called as crystalline and amorphous solid. Crystalline solids and amorphous solids. So what do you mean by crystalline solids? Okay. A substance is said to be crystalline solid when the arrangement of the units of matter inside it is regular and periodic. Okay. The units of matter may be ions, atoms, or molecules. Suppose in a system, in a solid, the arrangements of units. So units are building blocks of the crystals. They may be atoms, molecules, or ions. If these atoms or molecules are arranged in a regular pattern and periodic pattern, then the substance is called as crystalline solid. Okay. So crystalline solid means it is a substance, or it is a solid in which the units of matter are arranged in a regular and periodic pattern. They are called as crystalline solids. Good example is NaCl. Okay, the common salt. Common salt is crystalline in nature. So crystals of common salt you can find out. Then the sugar. Okay, sugar is in the form of crystal. Okay. So amorphous solid and crystalline solid, you can find the difference easily. Amorphous solids are not having the regular arrangement of units, and they are looking like very smooth solids. Okay, so there you cannot feel the crystalline nature there. Okay, so sugar, common salt, they are the simple example. Or chemically, you can find NaCl, okay, KCl, then zinc sulfide. So different examples you can take. Diamond, so they are the good example for crystalline solids. Then in amorphous solid, what will be the structure? There is no order in the arrangement of their constituent particles. Okay, in amorphous solids, the arrangement of particles are not in a particular order. They are not regular and they are not periodic. So crystals can be distinguished from amorphous substances by their anisotropy and symmetry. Okay, so these two terms are very important. Crystals are symmetric in nature. Okay, they have particular symmetry. If you operate the symmetry operations on the crystal, so that will not change its structure. Okay, so symmetry means in a particular direction, it is having the regular arrangement. Okay, simple example for symmetry is our body. Human body is symmetric with respect to the vertical line passing through the center of the body, or vertical plane passing through the center of the body. Human body is symmetric. And if you take the butterfly, so butterfly is exactly symmetric with respect to its center. Okay, so the wings of the butterfly are symmetric in nature if you observe in nature. Okay. Then the flower petals. Okay. Flowers are symmetric. If you take the flower with 5 petals, okay. So almost flowers have a good symmetric in nature. Okay. Sometimes some defects may occur, but you can find the symmetry in flowers, symmetry in butterfly, symmetry in human body. Okay. So lot of symmetry examples you can find in nature. These crystals are symmetric. Symmetric means they are having the particular arrangement. Okay. So in view, if you look at the crystal, they will have certain symmetry. Okay. About certain axis or about certain planes, etc. Then anisotropy. Anisotropy means some crystals may be looking different in a particular direction. If you observe that perpendicular direction, if you rotate it by 90 degrees, then that may have different symmetry. Remember, symmetry is must for a crystal, but symmetry may change if you change the observation of the direction of observation of the crystal. Okay. So anisotropy means with respect to certain direction, it is having certain symmetry. With respect to some other direction, it may have different symmetry. So they exhibit anisotropy and symmetry. So crystals are having important property called symmetry. Okay, symmetry irtadante. But amorphous solids are not having any order of arrangement. They are irregularly arranged. Okay, example is some powders. Okay, if you take talcum powder, so that is amorphous solid. Okay, very nice powders if you take, then they are good example for the amorphous solids. Okay, they are not having crystalline nature. Then how these atoms are arranged in nature? Basically, the atoms are arranged in a periodic arrays. Okay, an ideal crystal is constructed by the infinite regular repetition in space of identical structural units in the form of parallelepipeds. Okay, so if you take a simple example of crystalline salt, common salt, household salt, so that is having crystalline in nature. You can observe the cubical structure, almost cubical structure you can observe. Okay, so that cube has large number of smaller cubes in it. Okay, and each cube contains the sodium and chloride atoms in it. Okay, just atoms irthadalli. So such a repetition of these atoms, structural units means they are atoms. Atoms are structural units. They repeat in 3 dimension. Okay, and that will construct a crystal. Regular arrangement irthadu. For example, if you take to understand the concept of crystal, you arrange the chairs in a particular row in a given volume. In the simple room only, you arrange the chairs in a particular way. Okay, so that in each row you can put 10 chairs. Okay, and at the equal distance, then beside that you create another row so that the distance between the chairs are equal. So that means chairs are structural units. The repetition of these chairs in a regular arrangement forms a particular structure. One structure anna kodutadu. Okay, so in the same way, the atoms are arranged in a crystal. Andre regular arrangement irtadu. From one atom to another atom, there is a specific distance, and in a particular direction, they are arranged in the form of parallelepipeds. Andre, if you keep the boxes one with respect to one beneath the other, okay, beside the other, then these boxes can be arranged. Let us take 100 boxes are there. You can arrange these 100 boxes in a particular fashion, and they will have symmetry. If you look at the arrangement of boxes in a particular direction, you can observe a nice arrangement. Okay, so symmetry you can observe. In the symmetry in the same way, these parallelepipeds are arranged. Cubes are arranged like this. In the simplest crystals, the structural units contain a single atom. If you take very simple crystal, the structural unit may be an atom. Okay, simple example is a diamond. Diamond is a crystal. Diamond contains carbon atoms. So carbon atoms are arranged in a regular fashion with certain symmetry. Okay, so that forms diamond. So that is the simplest crystal. So the simplest structural unit can be atom. Okay, so structural unit may be atom, molecules, or ions, or group of atoms. Okay, it may be different in different crystals. More generally, the structural unit contains several atoms or molecules. Okay, a crystal may be composed of more than one chemical element. Example, NaCl. So NaCl consists of the structural unit as NaCl molecule. Okay, it contains two atoms. Or it may contain associated groups of identical atoms, as in diamond. Diamond has group of carbon atoms. Okay, so that may be the structural unit. Group of atoms may be the structural unit in some crystals. The structure of the crystals is described in terms of single periodic lattice, but with a group of atoms attached to each lattice point. What is lattice will come to later. Basically, structure is formed by putting the atoms in a lattice point. Lattice point, what is lattice point will take later. This group of atoms is called as basis. Okay, NaCl is a basis. The basis is repeated in space to form the crystal. Basically, that basis will repeat in space. NaCl, if you take the NaCl as an example, NaCl molecule will be arranged in a regular fashion, just like a chair. Chair is a basis. Okay, so one chair is a simple basis. If you repeat that basis in regular arrangement, then that will form a crystal. Okay, that will form a structure. Then if you make a marking, okay, before putting the chairs, if you make the markings before putting the chairs, then that marking can be considered as lattice point. Okay, so what do you mean by lattice? Lattice is a imaginary arrangement of points, and each point can be occupied by a basis. Basis is a structural unit. We'll come to that later, so we'll understand it clearly. So what do you mean by crystal translation vectors and lattice will take? So an ideal crystal is composed of atoms arranged in lattice defined by three fundamental translation vectors. Okay, so just a minute. It is defined by fundamental translational vectors A, B, C, such that atomic arrangement looks the same in every respect when viewed from any point. Okay, let us take the example of arrangement of chairs. Okay, if you take the arrangement of chairs in a room, then you can imagine a coordinate system. Okay, let us take the Cartesian coordinate system in space. So x, y, z are the coordinate axes. With respect to x, y, z axis, the points can be identified. Okay, the position of the chairs can be identified. If you draw a line corresponding to x-axis, and that is called as a vector, with respect to that direction, if you move the entire system along that direction, that will not change the structure of the system. Okay, ಅಂದ್ರೆ ನೀವು group of chairs ಒಂದು 50 ಚೇರ್ 5 ರೋದಲ್ಲಿ ಇಟ್ಟಿದ್ರಿ ಅಂತಂದ್ರೆ you can move those chairs in x direction. Let us take one part of the room to the second part of the room. You move it simultaneously. All the chairs has to be moved. Then it will not change the structure of that system. And that direction is called as translation vector, fundamental translation vector. Okay, you can translate the system from one position to another position, entire system. That will not change the structure of the system. Similarly, you can move along y direction. You can move along z direction. Okay, it will not change the structure of the system. And these vectors are the directions along which you can move the system entirely, and that will not change the structure of the system. Okay, so it means that the atomic arrangement looks the same in every respect when viewed from any point. Okay, if you observe from any point, it will look same. So there will be certain symmetry. There will be a systematic arrangement, and that is how you can understand the basic translational vectors ABC. A lattice translation operation or crystal translation operation is defined as the displacement of crystal parallel to itself by the crystal translation vector. If you move the entire crystal from one position to another position, its structure will not change. Okay. So that the translational vector can be defined as T is equal to N1A, N2B, and N3C. So that means if you move the crystal along direction A by a distance N1, by a distance N2 along B, by a distance N3 along C, then the entire system will not change its structure. Okay, that is called as translational operation. Okay, that means it is just like moving the box from one position to another position in the direction of A, in the direction of B, and in the direction of C. Okay, so they are called as translational vector. Our directionally move ಮಾಡಿದಾಗ structure change ಆಗಬಾರದು. Okay, so that directions are called as translational vectors ABC. Okay, understood. So ನೀವು ಯಾವ್ಯಾವುದೋ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. You have to move it in a particular direction so that the structure of the system cannot change. Okay, so that is how you can understand translational operation. And here N1, N2, N3 are arbitrary integers, that is distance mode. Okay, translated, the distance by which the system is translated. A vector T connects any two lattice points. Okay, if you move the system from one position to another position, then it is just like moving the system from one group of lattice point to the another group of lattice point. Lattice points are markings. Okay, ಅಲ್ಲಿ ನೀವು items ಅಲ್ಲಿ arrangement ಮಾಡಬಹುದು ಅನ್ನುವಂತ ಒಂದು marking, that is systematic marking. Okay, so the entire system will move from one group of lattice point to the another group of lattice point by the translation. Okay, so that is how we can understand. Just I will show you, I will try to show the example later. So what do you mean by crystal lattice? We'll try to understand it first. We know that crystal is constructed by infinite repetition in space of identical structural units, atoms, molecules, or ions. So atoms, molecules, and ions are arranged regularly in space that will create the crystal. Okay, you can take the example of NaCl. So crystal is formed because of the regular arrangement of NaCl molecules. If each unit is replaced by an imaginary geometrical point, the result is the pattern of points having the same geometrical properties as that of the crystal. So just like I have told you, if you replace these atoms by markings, that is geometrical point. So you remove all the chairs. Okay, take the example of chairs only. 50 chairs are there. So remove all the chairs and replace these chairs by certain markings. The dot geometrical points in the then this group of points gives you same structure as that of the group of chairs. So these imaginary geometrical points having the particular structure of the crystals only, they are called as lattice points, and this group of lattice points is called as lattice or crystal lattice. Okay, so this geometrical pattern is called as crystal lattice or simply the lattice. The points are called as lattice points. Okay, if you put the chairs on the lattice point, that makes crystal. Okay, so chairs are called as bases. Bases means they are the structural units. Structural units are called as bases. That means if you put bases on the lattice points, that will create the crystal. Okay, that means crystal lattice plus basis gives you crystal. So crystal lattice is an imaginary group of points or imaginary geometrical points that will have the properties of the crystal. okay, with respect to symmetry and with respect to its structure. So finally, you can define the crystal lattice, the regular pattern of points which describe the three-dimensional arrangement of particles. The regular pattern of points which describe the three-dimensional arrangement of particles, they are atoms, molecules, or ions, in a crystal structure is called the crystal lattice or spaced lattice, or it is also called as lattice. Okay. So regular pattern of imaginary points, geometrical points, that will give you the structure of the crystal. Okay. And that is called as crystal lattice. So remember, the markings are lattice points. Group of those lattice points are called as crystal lattice. Remember, crystal lattice is only giving you the nature of the crystal. Yav tara irtade, yav tara arrangement irtade annodana matra kodutade. If you put the crystal units, structural units on the lattice points, that will create the crystal. So just I will show you an example after taking this meaning of basis. Basis means the crystal structure is formed by associating with every lattice point a unit assembly of atoms or molecules identical in composition. Okay. So crystal structure is formed by associating each lattice point with a unit of assembly, okay, unit assembly or structural units called atoms or molecules. This unit assembly is called as basis, that is individual structural unit, atom irbodu, molecule irbodu, etc. In NaCl, what is the basis? Basis is NaCl molecule is a basis. Common salt, what is the basis? The basic structure is NaCl molecule, that is a basis in the common salt. So that is the structural unit, okay, fundamental unit in common salt. Okay. Sugar, sucrose is a structural unit. Like that, you can understand the meaning of basis. The basis may be a single atom, or it may be a molecule, or it may be a group of atoms or molecules. Okay, it may be group of atoms or group of molecules. In sugar, you can understand the structural unit as sucrose. Sucrose is a group of atoms. Okay, it may have some carbohydrate, etc. Group of atoms are present in the sugar. Then finally, what is crystal structure? First, you have seen lattice, crystal lattice andre ಏನು ಅಂತ ನೋಡಿದ್ವಿ. Then we have seen what is basis. Then what is crystal structure? The crystal structure is formed by addition of basis to every lattice point. That is called as crystal structure. That means lattice plus basis, that gives crystal structure. That is very important. The crystal structure is real, whereas lattice is imaginary. I have already told you, lattice is a group of imaginary points, okay, markings. These markings can be occupied by basis. What do you mean by basis? Basis is a group of atoms. So crystal structure is a real, whereas a lattice is imaginary. Okay. So just you can observe this figure. Here, figure clearly illustrates the difference between crystal lattice and basis and the crystal structure. Note the difference clearly. The crystal structure is formed by addition of basis, which is given in B, to every lattice point of lattice A. Figure A is a crystal lattice. Figure B is basis. Figure C is crystal structure. By looking at C, we can recognize the basis and then we can abstract the space lattice. So basically in nature, crystals are present. Okay. These are imaginary. We have to understand the concept behind this crystal. Crystal structure is present in nature. So you can observe the structural unit here. Even observe madidre, you can understand this is a structural unit. This is the fundamental building block. Okay. Containing two atoms. It may be NaCl. Okay. So one sodium atom and one fluorine atom. Okay. So this will be the basic building block. And this is repeating in this direction, in this direction, in this direction, etc. So it's a two-dimensional lattice, sorry, two-dimensional crystal. It is repeating its arrangement in two directions, along X direction, along Y direction. Okay. What is the building block here? this molecule is a building block, and that we call it as basis. If you remove each and every atoms here, every structural unit, you will left with certain points. These are the points, and this is actually the arrangement of the structural units in the crystal. So this gives imaginary markings, and that gives you the nature of the crystal structure. The crystal structure is real, whereas crystal lattice is imaginary. Remember, this is imaginary. We can extract this crystal lattice by looking at the crystal structure. The crystal structure nodi basis yaudu idralli anta find out madabodu. What is the crystal lattice you can find out. Okay. So if you replace these points by this basis, each point is replaced by this basis, that gives you crystal structure. So crystal structure is having certain arrangements in a regular fashion, and that arrangement is done by using basis. Remember, crystal lattice or lattice points are not exist in nature. They are imaginary. For our understanding, we are making these points, just like the rangoli. Okay, rangoli points you can find. Then this is having certain symmetry. You can observe this is exactly symmetric with respect to x direction and y direction. If you look about this one, it can have certain arrangement like this also, certain arrangement in this direction, and these points are arranged regularly. So there is a repetition and regular arrangement. Okay, so remember, crystal lattice is a imaginary geometrical points. Okay, and that is having certain symmetry, and that shows the crystal structure. Basis is a structural unit. Okay, and that constructs the crystal. So crystal structure is observed by putting the basis in each lattice point. That is called as crystal structure. So finally, you can remember crystal lattice plus basis, that gives you the crystal structure. Okay, so three things you have to remember. Then what is unit cell? We'll complete it today. What is unit cell? In a crystal, the atoms are arranged in periodic array. So periodically the atoms are arranged. It is possible to isolate the representative unit cell in each variety of crystal. Okay, you can find out what is the basic building block in a crystal. Okay, for example, in NaCl, cube is the basic building block. Okay, a repetition of cube you can find out. So unit cell is a three-dimensional structure. Okay, that is the fundamental building block. Okay, so then this unit cell may be group of ions, atoms, or molecules. Okay, just I will try to explain it properly. The crystal is constructed by repeatedly translating the unit cell in 3 dimensions. So just I will show you the figure of unit cell. Before that, we will define it. The smallest portion of the space lattice, which can generate the complete crystal by repeating its own dimensions in various directions, is called as unit cell. So in this crystal, this square is a unit cell. You remember. So this is one type of crystal structure. Sorry, it is a crystal lattice. In this lattice, this square is the unit cell. That is the fundamental building block. This square is repeating in 2 directions. Okay, because the distance in x direction, distance in y direction is fixed by this square or rectangle. Okay, it may be not perfect square, it may be rectangle. So rectangle is the basic building block in the crystal structure. This is called as unit cell. This is the smallest portion in the crystal. Repetition of this smallest portion in different directions, in x direction, y direction, along diagonal direction, that will produce the crystal lattice. So that smallest portion is called as unit cell. The smallest portion of the space lattice, which can generate the complete crystal by repeating its own dimension in various directions, is called as unit cell. That unit cell can be distributed in different directions. Take the example of boxes. 50 boxes are there, and you have to arrange them regularly in a room. Okay, or in a particular box, bigger box. The room alli you arrangement madabekandre you have to arrange it regularly. Okay, so one box, if you place that, that is the size of the particular smallest portion or building block. So beside that, you can put the another box. Beside that, another box. You can repeat it in different direction so that you can put maximum number of box by using the regular arrangements. So that smallest portion is called as unit cell. So in this figure, this rectangle is a unit cell. You remember this. Okay. So that is what the meaning of unit cell says, or definition of unit cell says. So this is the simple unit cell. We'll complete this. So this is an example for unit cell. Then unit cell is having certain property. In three-dimensional structure, unit cell is having the cubical structure or certain parallelepiped structure. Then it can have three different sides. Okay, three different edges, and parallel to them, there are a number of edges are there. Along x-axis, along y-axis, and along z-axis, they can have the regular distance between one atom to the another atom, or one basis to the another basis. And in a unit cell, or unit cell is defined by using the length of the edges and angle made by the sides of the cube or sides of the parallelepiped. And here we identify OA from the origin to the A, where another basis is there. The distance is A. Along y direction, distance, that is edge of the cube, is B. Edge of the cube is C here, if you take it as a cube. Then these are called as dimensions of the unit cell. Length, breadth, height. That is the dimension. And here along x direction, what is the length of, or what is the distance of one basis to the another basis? Along y axis, what is the distance? Along z axis, what is the distance? They define the distance dimension of the unit cell. Then angle between A and B. Angle between this A and B is alpha. Okay, sorry, I think I have given a little bit different. Okay, A and B I have taken gamma. Between B and C it is alpha, and between C and A it is gamma. So they are called as interfacial angles. Just I will correct it. So they are called as interfacial angles. So angle between these edges, they are called as interfacial angles. And these values A, B, C and alpha, beta, gamma gives you complete structure of the unit cell. And here the vectors ABC define the axis of the crystal. Okay, so ABC are translational vectors. Along these vectors, you can translate this unit cell, and that gives you the repeated structure, and that will give you the complete crystal structure. Repetition of unit cell you can do along ABC direction, that is along X, Y, and Z direction. Dimensions of the crystals and the structure of the crystals are defined using the properties of the unit cell, that is by dimension and the interfacial angles. Okay, remember this. So primitive lattice cell we'll consider in the next class.